Hi, my name is Jake Robinson, and I'm really excited to be here today for this VMUG virtual event to talk to you about developing, testing, and publishing your PowerCLI scripts in the enterprise. If we've never met before, I'd love to get to know you. I have over 9 years of infrastructure automation experience. At VMware, I've been a developer, a dev manager, and most recently, I am the product manager for PowerCLI, ESXCLI, DCLI, and VCLI, basically all the CLIs. You can find me on Twitter and GitHub and the VMware Code Slack channel at Jake Robinson. My personal blog is geekafter5.com. And if you're not part of the VMware Code Slack channel, you can join at code.vmware.com/join. One of the benefits of being the product manager for PowerCLI is I get to tell you what we've done over the last year, and then also give you a sneak peek into what we're currently working on. So PowerCLI has had 4 releases this year, which is pretty amazing. The team has done a really excellent job in improving our automation for testing and getting releases out the door, and we hope to continue improving that. Starting in PowerCLI 6.5.1, we are now in the PowerShell gallery, which is really amazing because it makes installation and updates very simple. So single command, install module vmware.powercli, and you have all of the VMware PowerCLI modules installed. When we get new updates, it's as simple as update module vmware.powercli, you have the latest code. Since introduction to the PowerShell gallery, we've had 75,000 installations of PowerCLI. We've released 2 new modules this year that I'm really excited about. The first one is the NSXT module, and the other one is the VMware Cloud on AWS module. Both I'm really excited about seeing growing. Right now, they're more low-level access to the APIs, and I look forward to us adding more commandlets that are super easy to use. So now in PowerCLI, our commandlet count is up to 632. That's 632 commandlets that you can use to manage your VMware environment. The team is hard at work porting modules over to .NET Core support for PowerShell 6. So hopefully soon you will see Linux and macOS support for PowerCLI. I'm really excited about the possibilities for this. Okay, let's start to dive into our main topic. This isn't a hard question, although some people might make it out to be one. The answer is, if you're writing text that a computer interprets as instructions, you're a developer. You might not be a paid full-time developer that read the design patterns book by the Gang of 4, cover to cover, has every pattern memorized, but you're a developer nonetheless. In case you weren't aware, the world is quickly moving toward infrastructure as code and away from this locked-in GUI management. We need to start investing more in our careers as infrastructure developers, not just point-and-click admins. So I saw somebody tweet this out of reInvent the other day. We're asking developers to be all these different things, IT ops, security, or are we? Everything is becoming code. Everything is becoming software. Software is eating the world. No matter how you say it, we all need to learn to code. We're not asking developers to do all of this. We need to become developers and be experts in our own areas. So part of adding development into our skill set, we need to learn software development release practices. So over the next 40 minutes or so, I'm going to walk you through the processes and the tooling that software developers use that we can apply to our PowerCLI scripts. And I put enterprise in the title for a specific reason. A lot of times in an enterprise, we might not be able to use some of the SaaS services that are out and available to us, either because we're not open sourcing our scripts, or maybe the process is just easier to run a server internally than it is to get all of the security waivers and legal waivers signed inside of our enterprise to have these external tools used in our pipeline. The four main things we'll talk about today are version control. How do I track the changes to my PowerCLI scripts? We'll talk about testing. How do I test these in a very efficient way that when I make changes, I know I'm not breaking things? We'll talk about publishing and really distribution. How do I package these PowerCLI scripts? And then how do I get them out to my fellow admins or maybe to other users within my organization? And then finally, we have to automate the process because that's what we do, right? So how do I orchestrate this entire process of going from a code commit to automatically testing and then automatically packaging, publishing, and distributing? Let's get started by talking about version control. Sometimes it's called source code management or source control management. Doesn't matter what we call it. It's all about knowing what changed in our code. And sometimes more importantly, when it changed and why it changed. There are many different version control systems out there like Subversion, Mercurial, but everybody nowadays uses Git, so that's what we're going to learn. I thought I'd share how not to do version control as well. You can see a list of vcheck files over here. These are the popular vcheck script that was edited a number of times and might have various changes in them for whatever reason. This is in my Dropbox today, so go ahead and yuck it up. I have no idea what's going on. But this is certainly the wrong way to do version control. So if you're doing this today, then this talk is absolutely for you. And remember, going back to Jake the dog, my spirit animal, sucking at something is the first step to becoming sort of good at something. So let's become good together. Git, as I said, is probably the most popular version control tool system out there. So that means there's a ton of learning resources available to us. But when it comes down to using Git, these are the commands that I probably use 98% of the time. This is setting up a new project, making commits, pushing my changes to the centralized system, and then maybe pulling a new version down. And then, of course, log and diff, basically tools to see what has changed over time. So let's just flip over to my console and play around with it here. So you can see I have a folder with my scripts in it. So if we do an ls, you can see script 1 and script 2. These aren't real scripts. We're just playing around with files. So it doesn't have to be PowerShell scripts or even code at all. It can just be text documents. So if you just look at this cat script 1. See, it's just a comment in there, my first script. So if we do a git init, so we can see that we initialized the repository. I had initialized it before, so it says reinitialized. And then we can do a git status. And we can see we're on our master branch. This is sort of the root. And let's go ahead and make a change to one of our scripts. So I'll just say vi script 1.ps1. And we'll just put something else in and say hello world. And now we do a git status, and we can see that a script has been changed. So it gives us some instructions on what to do next. It says no changes added to commit, use git add or git commit -a, which commits all the files that have changed into a new commit. So we'll just say git add script 1.ps1. Sorry for the dinging. Just mute that. And now we can say git status again, see what's going on. You can see that these changes are staged. They're not committed yet. We've added the file to this this commit, but we actually haven't committed it yet. So we can say git commit -m, -m, and here's where we put in the comment for the commit. So you want these to be meaningful. You don't want to just say made a change. Like that's the bad way to do it. Or you know, sometimes people you know, take out their frustration, like please work, something like that. We need to put in something meaningful. So we made a comment to this. So we say added comment on, we don't necessarily have to put the line number, about saying hello. All right, so we have one file changed and one line insertion. So now we come back to get status and we say there's nothing to commit, everything's clean. And the next thing we would want to do is maybe push it to our centralized server. Now I don't have anything set up centralized yet. This is all change control on my local machine. So you can start doing change control right now during this talk. You can even follow along if you wanted to. I happen to have GitLab set up on my machine running in a Docker container for this talk, so we'll flip over to that. And we've been blinded by the white screen going from the dark. Super awesome. But we're going to create a new project here. So I'm going to click create a new project. And we're going to call it my scripts. And just a little note on strategy here. You might have a single Git repository with many scripts in them. You might, depending on the size of the script, you might have one script in a single repository, or you might even have a module in a repository. If it is a module, I highly recommend making it a single repo. So let's put in a little project description here. And then we'll just change the visibility level to public. It really doesn't matter, but it might help us do this a little bit easier. All right, so we've created, this is GitLab, by the way, if I didn't mention that. We've created this new empty repository. And since we have an existing Git repository, we can run these commands to push up all the code that we already have. So we'll flip back over to the console. Move this around a little bit, and we'll say git remote rename origin old origin. I don't think we have an origin in there, but it's all right if we do that anyway. And then we're going to say git remote add origin I think I'm on localhost, obviously, since this is a Docker container, and I put it on port 81. I am root, not Groot. And my scripts.git. All right, so there we go. So now we can git push -u origin --all. And you can see that that was successful. And then if you have any tags in there, you can say git push -u origin --tags. We didn't have any tags. We just made code changes. Tags are what you can use for specific versions. So you can tag a particular commit with a version or a code word name, whatever. And there we go. Now, sometimes if we're working on a team, somebody else might have changed something, so we can say git pull origin, and it'll pull down the latest code that somebody else has committed to that. So that pulls that from that centralized server back down, and then we are up to date at that point. The other commands that I mentioned before are log and diff. So you can say git log, and this shows you all the different commits that I've made. And we can say git diff. This actually works better if I say vi script. You can actually diff two commits, but I don't feel like doing that. So let's just put in something else, literally something else, and then we will say git diff script 1.ps1, and you can see that highlighted in green there, I've added the line something else. So it's actually comparing head, basically what we're working on, to the previous commit. And what you want to do for running Git in the enterprise is, first of all, start using it locally. You don't need to set up a external server or system in order to get started right away. You can store that stuff locally. You can even save all those changes are tracked inside some files, and you can store that on Dropbox or network drive. But there's some serious power in a centralized system like GitLab. GitLab comes in a community edition as well as a paid enterprise version. So if your organization is not up on using free open source community software, but you might need some support along with it, then GitLab does have that enterprise version. And then of course there's GitHub Enterprise. So if you're already used to using GitHub, or maybe you want the GitHub feel, then GitHub Enterprise is also available. Okay, our next section is testing our code. And this seems like a hard sell sometimes when I talk to IT admins that are writing especially PowerShell scripts. Testing, might double or even triple the code that they have to write sometimes. So it can up front seem like it's not worth it. It takes longer to get code out the door, but there is a larger upfront development cost for sure, but it's going to save time in the long run, both in a debugging standpoint and also releasing our code. And it's not just IT admins that sort of buck this idea of writing tests in our code. I've talked to a lot of developers that really hate writing tests as well. So it's not unique to any sort of group of people. It's just sort of a human thing that feels like we're adding additional work for no value, but there is a ton of value. There's this concept of red-green refactor when it comes to test-driven development, also called TDD, where we write specifications for what we want our code to do as tests, and then we write the code to satisfy that test, and then we can go and make the code better and faster. So they call it red-green refactor. So we write our tests, we run our tests, and they're red, they fail. And then we write the code to satisfy those tests, and the tests turn green. And then we refactor. We constantly make our code better, and hopefully our tests stay green. If they go to red, then we know we broke something. This is much less costly than running your code in production, only to find you mess something up and maybe cost yourself hours of headaches, not only fixing the code, but also fixing production. And that's what tests save us from. If you're brand new to this idea of testing your code, this vocabulary helped me out when I was first starting. So hopefully this will help you out as well. So first of all, we have unit test, an isolated test of the smallest amount of testable code. Now, the smallest amount of testable code could be as simple as a function, could be smaller, but generally, a function or a method is a testable unit. Some people go bigger, some people go smaller. So really, it ends up being on you what you define a unit is. But The other key word here is isolated. So we are isolating this code from everything else. We don't have to have a big environment stood up that integrates with all these different systems to test this code. So unit test, isolated test, small amount of code. Compare that to an integration test where we're testing with other pieces of code, maybe multiple functions or methods at once, or maybe even some external systems, possibly in like a development or staging environment. Generally, unit tests are very fast, very quick. They happen in seconds for all of our tests. And then integration tests are generally long-running things that might take an hour or even longer, depending on the size of your scripts and your code. The other kind of tests we have are called static code analysis. And what we're doing with these tests is actually reading the code itself, looking for different things that are not very good practice, tabs versus spaces, but I won't get into that argument. But also, certainly indentation is one, but if we're using bad variable names or bad functions, I think that PowerShell has one that looks for usage of write host, which could be bad in some environments. And then also, if we're ever publishing to the PowerShell gallery, the static code analysis, I think it's called PS Script Analyzer, actually uses static code analysis to look for different things in the scripts before they actually get published as well. An assertion, really what our test actually is, a comparison of what we believe should happen and what actually happens. So we run the code and we say the output of this code should be this object type or this value or something along those lines. So that's the assertion that we make. And a mock is a pretend object or a fake call to an external system that might do some calculation for us, but essentially returns a fake value so we can isolate our unit tests. So mocks are extremely important in isolating our code so we know we're only testing this one little bit of code and we don't have failed tests due to some external code or external system that might fail along the way. Mocks are really the magical thing that make our unit tests go so fast that we can test a large amount of code in seconds. Different languages and different runtimes come with testing frameworks, and Microsoft and the PowerShell team use Pester. Pester comes shipped now with PowerShell and I believe Windows Management Framework 5 and above. They have some pretty good documentation on GitHub. It is open source, so you can go look at what it's actually doing. And there's also a pretty good getting started guide at this link here that I'll make available to you. Let's flip over to the console and I'll show you a quick example of some Pester tests in action here. So I'm going to go over to my console and I'm going to change my directory to a little Pester example I have set up here, and if we look, you can see that I have both a script, really two scripts. One has tests in the name and the other one doesn't. So let's just take a look at our add numbers script here. And you can see it's just a function that takes two numbers and returns the one number plus the other number. So fairly straightforward. Just a simple function, and then we'll go ahead and we'll actually open this up in Vim, and you can see here are our tests. There's some little path manipulation here, but we have this description code block, and inside here we have our assertions. So we can see they're fairly straightforward. You can almost read them in English. It adds positive numbers. So we look at our assertion, add numbers. So it runs the script 2 and 3. And then our assertion is that it should be 5. So 2 plus 3 is 5. Fairly straightforward. And it's basically the same, throughout all these tests. And notice that I have multiple tests. I have multiple test cases for a single function. So really we're quadrupling our the amount of code that we have to write here. Although most of this is just description about what it's doing. It's fairly easy to write. We do have to think about what we're testing and what assertions that we're making. So let me get back out of here, and I'll open PowerShell in my Mac, which is pretty amazing. And you can see that I'm in my PowerShell session now in my pester example directory, and I'm just going to invoke pester. And what this is going to do is just go and look for all the test files inside of this directory and run everything in there. So let's give it a shot. Great. So you can see everything's green, so green is happy. It adds positive numbers, it adds negative numbers. So all of our tests have passed, 0 failed, 0 skipped, etc. So why don't we go have a little bit of fun? And that's not what I want. Also not what I want. Vi add numbers.tests. Let's just do a little fuzzy math here, right? So 2 plus 4 should be 5. That's our assertion. It's an incorrect assertion, but it is an assertion. All right, so we're going to invoke pester again, and this is what it looks like with the failed tests. So not only does it give you the fact that it failed, but it also tells you the difference in the value. So we expected 5, but we actually got 6. Tells you exactly what line it's on, so you know without a doubt where the problem is. Okay, so let's talk about static code analysis. I mentioned before that static code analysis is really looking at the code itself to make sure we write high quality code, we write things consistently, and we don't use some of the bad maybe methods that might cause us problems. So PowerShell has something called the PS Script Analyzer. It's really easy to install. Just install module PS Script Analyzer, and then we can run it against any number of PowerShell source files. These are really freebie tests, so I would always run these against my PowerShell scripts to make sure that I have the best quality code. So now we have our code written and tested. We need to maybe get these out to our fellow team members to actually use. So certainly a shared folder might be one option, but keeping track of the different versions of the script or module might be a little difficult when we face reality. So someone might update a script. We don't know if we have the latest or not, and that's where a centralized artifact repository comes into play. You might already be familiar with the PowerShell gallery, and that is an artifact repository for PowerShell modules and scripts. But you might not have gone through your internal security practices to, first of all, download scripts or modules from the PowerShell gallery, but also we might not want to publish our own organization's scripts on a public repo. So we want to set up our own internal artifact repository. Makes it very easy to install and update our scripts and modules that we write internally. It has built-in installation validation, so it does all the hash checks for you. And we can also, which is very cool, and I recommend this for PowerCLI, is we can host externally written modules that maybe have gone through some approval, security validation that we can host internally on our own artifact repository as well. So just a side note on licensing or redistribution of PowerCLI, you're free to redistribute PowerCLI internally as much as you want. So as long as it's within the same organization, it's perfectly fine. The current license just does not allow you to, say, host PowerCLI on a public repository or include it in any of your virtual machines or appliances that you send out. There are two very popular artifact repositories out there. The first one is Sonatype Nexus. The other one is JFrog Artifactory. The biggest difference between these two that I've seen is the licensing. So Nexus allows you to host NuGet repos with their free edition. I'm pretty sure they have an enterprise edition too if you need that additional support. And JFrog Artifactory, in order to get NuGet repos, which is what PowerShell uses, we actually need to pay for the enterprise license. So I'll be doing a demo here of the Nexus artifact repository. So I've switched over to my Windows virtual machine. Unfortunately, publishing scripts and modules does not work on the current macOS or Linux version of PowerShell, so hopefully we see that in the future. But if we look here, apologies. If we look here, I just have an add numbers PS1, and we're going to be publishing that to our artifact repository. So let me switch over to my artifact repository and show you what that looks like. So here's our Nexus repository manager, and you can see that I've just created a repository. It's very easy to do. Create a PowerCLI repository here, and then under security, I think we already have a NuGet API key, so you can access your NuGet API key here, which is required for publishing our scripts and modules to our artifact repository. So I'm going to come back here, and we can say get PS repository, and you can see that I have my repository called my.org, installation policy trusted, and the address of the repository. And in order to publish this script to our repo, we need to first update the script file info. So that script file info is what the PowerShell get uses for metadata, so you can find different scripts and files, modules in your artifact repository. So we can update script file info. In fact, I think I've done this already, so I can say update script file info, and you can see the very well, thank you, Java. You can see we're forcing it, and the path is just add numbers .ps1, and then we put in a description and a version. So we'll go ahead and do that. No errors. We can actually run a test script file info. Put in our file name here. Whale. Do that. You can see version 1.0, add numbers, author someone. I didn't really write the script, so in description, add 2 numbers. Great. So we can now publish our script. I already have that here, so I'm adding in the path to my script locally what the repository is, which is my.org, and then the NuGet API key is this long sort of GUID here, and we're just going to do verbose. So hopefully if I hit enter, and there we go. So last line, successfully published script, add numbers to the publish location, etc., etc. It says please allow a few minutes for it to show up in the search results. So I've had some issues with the find script and save script, so it seems like PowerShell get is a little buggy when it comes to this stuff. So if we do a find script, we say add numbers You can see that there was no match found. This is really interesting because if I do a find module add numbers, we can see that it actually shows up in there. So I think there's some little buggy situations going on with scripts versus modules. What I like to do actually for scripts is find package, and you can say source my org, and you can see that we actually have the package there. And then what we can do is we can do a save package, add numbers, the source of my org, and then we can say just put it on my desktop. So there we go. We have the latest version of the script on our desktop. So hopefully we'll see some bug fixes soon for PowerShell Get. And of course, this is all open source. So please, if you have some time to contribute, it would really help the community out and certainly help me out. And I do plan on making a couple bug fixes to PowerShell Get myself. So let's do it together. Okay, so back to the slides. And one more note before I move on, everything works fine with modules. So if you're writing modules internally, which is good practice anyway, if you're writing modules internally, the publish and install module and update module all work perfectly. So that all is great. It's just the script part that's a little flaky. So we looked at Nexus. There's a link to both JFrog Artifactory and Nexus there. There are a couple good guides that I've found. First, Brian Bunke has a pretty good script publishing example. Again, there's some funky stuff going on with install scripts, save scripts, stuff like that. But he walks you through the process of the script file info and actually publishing to the PowerShell gallery if you want to look at that. And then this guide is what I followed for installing Nexus. Super simple guide. I had it up and running in about 5 minutes. So if you want to try it out, this is a really easy installation. So now we get to the fun part of this exciting adventure where we automate the entire workflow. This can be called continuous integration, continuous delivery, depending on sort of some variables that are in there. But what it comes down to is orchestration of this entire process of writing code and then delivering a final packaged product. So we commit new code, and then we test code, and then we want to publish code. It's as simple as that. So what is sort of surrounding all of this? What tools do we use as admins to do that? And the answer for me has been Jenkins for some time. So I'm going to flip over to Jenkins and show you just a little example pipeline of a module that I created called vCloud Backups a few years ago. And I'll just sort of walk through the pipeline. It's super easy to set up. I won't go through that. But there is a really good guide that I'll give you a link to after we show you. So believe it or not, this is actually Jenkins. If you used Jenkins in the past, you know that it doesn't normally look this good. But this is a project called Blue Ocean. And I thought it was amazing to display the pipeline that we're going through here. So you can see there's the start on the left-hand side right here. So anytime we commit code, so I'm doing that git push, that's where this starts. So Jenkins will listen to hooks on GitLab or GitHub Enterprise or GitHub or whatever, and then it'll start this pipeline off. So once we start off, you can see there are two parallel tasks here. So we're running our PS script analyzer and we're running Pester. I'm not sure why it's named the way it is. I guess this is the Pester stage, and then we have the PS script analyzer job and the Pester job here. But anyway, they're two parallel tasks. So we're actually taking two different testing jobs and running them in parallel. So we're saving maybe a few seconds there. In bigger jobs, maybe those are integration tests, we might be saving minutes or hours. But anyway, so once that is done, then we're going to create our module manifest or our script file info. And once that is passed, then finally we're going to publish to our artifact repository. And that's it. That's a simple pipeline to go from PowerShell code, your PowerCLI scripts, all the way to a published script or module. So again, what you just saw was Jenkins. If you're not familiar with Jenkins, you can go to Jenkins.io and learn more. If you really like that Blue Ocean plugin I just showed off, that link is there for you. And for building out your module pipeline, I guess it's Ziny, has a great blog on it, very lengthy, very detailed on how to set this up, and even I think has some scripts to help you out in the process. So let's wrap up this talk by talking about what we learned. First of all, if you didn't know, we're actually developers. We might not be full-time developers or necessarily even paid to be developers, but that's what we do. Data center automation is a fact of life nowadays. We learned about source control and using Git to do some very basic things, like initializing a Git repository and doing commits and pushing our code. We learned about Pester and what unit tests are and what static code analysis is, sometimes called linting. I didn't mention that earlier. But we learned about the value of testing and how to get started in that. We learned about artifact repositories and how we can host our own internal PowerShell gallery, not just for the code that we write, but also external modules like PowerCLI. And then finally, we learned how to automate the entire process using Jenkins to orchestrate that code pipeline from code commit all the way to packaged module or script. Please come say hello on Slack. You can sign up at code.vmware.com/join. I would love to hear what you learned, or maybe talk with the community and share some additional information or experience that you have in this area. On behalf of everyone here at VMware and VMUG, thanks for attending this VMUG virtual event, and talk to you soon.